Good day to everyone. I'm here to present light-related transducers, specifically the photodiode, PhotoSCR, and PhotoSCS, and including the PhotoTRIAC.
What are photodiodes? A photodiode is a p-in junction or PIN semiconductor device that consumes light energy to generate electric current. It is also sometimes referred as photodetector, photosensor, or light detector. Photodiodes are specially designed to operate in a reverse bias condition. Reverse bias means that the P side of the photodiode is connected to the negative terminal of the battery and N side is connected to the positive terminal of the battery. In a normal PN junction diode, voltage is used as the energy source to generate electric current, whereas in photodiodes, both voltage and light are used as energy source to generate electric current. Features of a photodiode. The symbol of a photodiode is similar to the normal PN junction diode, except that it contains arrows striking the diode. The arrows striking the diode represent light or photons. Photodiode should be always operated in reverse bias condition. Applied reverse bias voltage should be low. Generates low noise, high gain, high response speed, and high sensitivity to light. How it operates. When a photon of ample energy strikes a diode, it makes a couple of an electron hole. This mechanism it is also called as the inner photoelectric effect. If the absorption arises in the depletion region junction, then the carriers are removed from the junction by the inbuilt electric field of the depletion region. Therefore, holes in the region move toward the anode, and electrons move toward the cathode, and a photocurrent will be generated. The entire current through the diode is the sum of the absence of light and the photocurrent. So the absent current must be reduced to maximize the sensitivity of the device. Modes of operation. Photovoltaic mode. This mode is also known as zero bias mode, in which a voltage is produced by the lighting photodiode. It gives a very small dynamic range and non-linear necessity of the voltage formed. Next would be the photoconductive mode. The photodiode used in these photoconductive modes is more usually reverse bias. The reverse voltage application will increase the depletion region's width, which in turn decreases the response time and the junction capacitance. Lastly is the avalanche diode mode. Avalanche diodes operate in a high reverse bias condition, which permits multiplication of an avalanche breakdown to each photo-produced electron hole pair. This outcome in an internal gain in the photodiode, which slowly increases the device's response. Application of photodiodes. These diodes are used in consumer electronics devices like smoke detectors, compact disc players, and televisions and remote controls in VCRs. Photodiodes are also widely used in numerous medical applications like instruments to analyze samples, detectors for computed tomography, and also used in blood gas monitors. These diodes are much faster and more complex than normal p-n junction diodes, and hence are frequently used for lighting regulation and in optical communications. What is a PhotoSCR? A light-activated SCR acts like a switch that changes states whenever it is exposed to a pulse of light. Even the light is removed, the light-activated SCR remains on until the anode and cathode polarities are reversed or the power is removed. Features of PhotoSCR. It may be triggered with a light source or with a gate signal. Sometimes a combination of both source and gate signal is used to trigger an SCR. The light intensity required to turn on the SCR depends upon the voltage bias given to the gate. Higher the voltage bias, lower the light intensity required. How it operates. When photons from a light source collide with electrons within the p-type semiconductor, they gain enough energy to jump across the p-n junction energy barrier. When a number of photons liberate a number of electrons across the junction, a large enough current at the base is generated to turn the transistors on. The picture would show the schematic symbol for the SCR. Applications of PhotoSCR. The light-activated SCR are generally used for an application which requires low power to operate. This is because power generated by SCR is low in magnitude. The optical light control used the principle of photoconduction for generating the control signals. Therefore, the LASCR finds extensive application in optical light control. Next would be the PhotoTRIAC. It is effectively a development of the SCR, or the thyristor, which is only able to conduct in one direction. The TRIAC is a bidirectional device. Unlike the PhotoSCR, the TRIAC operates ideally when AC is used, since it can control the current flow over both halves of an alternating cycle. And the last would be the PhotoSCS. Unlike the SCR, the SCS is a semiconductor device that has 4 layers of silicon doped with acceptor and donor impurities, but with all 4 of the P and N layers made accessible by terminal. When a light beam hits the active light-sensitive surface, the photons generate electric hole pairs that can make the device turn on. Removal of light does not reverse the switch, can be turned off only by removing or reversing its positive bias. Its application would also be the same as the PhotoSCR, given that it has an extra gate which it can operate on. Thank you.